Okay, here is number 4 on practice 2, and let's see, why is this not working? Okay, let's see if we can make this work. All right, so here we go. So this is an astronaut of mass 80 kilograms carries an empty oxygen tank of mass 10 kilograms. By pushing the tank away with a speed of 2 meters per second, the astronaut recoils in the opposite direction. Find the speed with which the astronaut moves off into space. Okay? All right, so my initial, I'm going to say to the right is positive. That is awful. Let's make something better than that. Whoa. Thought I just wanted the pencil. Let's try this one. Whoa, that's awfully, wow, that's too big. That's not working. Tools, pencil. How about just pencil? Sorry about that. Okay, make it a little thicker and then we'll be good to go. I should probably start over, but nah. Okay, all right, so here goes the astronaut. Okay, and he's holding an oxygen tank. Okay, and he says he's carrying it. So they don't really say what's happening. So we'll say this way is positive. So we're going to say their velocity is 0. Okay, and then the mass of the astronaut is 80 kilograms, and the tank is 10 kilograms. Okay, so since they start together and then come apart, this is an explosion. So then what's going to happen is we'll still say to the right is positive. The oxygen tank is going to head off in this direction at 2 meters per second, and then we want to find the velocity of the astronaut. Okay, and we can assume it's going to be in this direction. We can kind of see what's going to happen, right? Newton's third law. They're each going to feel a force, and they're going to move off in opposite directions. Okay, so let's make maybe one box 10 kilograms. Hopefully that's going to fit. All right, and it's going to be a little tough with the velocities because we kind of don't know what they are. So I think I'm going to wait on this until we get some idea on how fast they're moving. Okay. Well, let's just try this. So sometimes you might do this and it might not work out. Okay, and then you might have to fix it, but let's just give it a try. Okay, so since it's going to be 2, I can kind of look and see that the astronaut, I'm assuming, is going to move slower, right? Because he's heavier. So I'm going to go ahead and assume this. Okay, so let's start the astronaut 80. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and he's not moving. That's the astronaut. Okay, and then make another color maybe. Green. Okay, and then here to here is the tank, and it's also not moving. Okay, after the astronaut is still going to be 1, 2, 3, 4, 5, 6, 7, 8 because it's 80 kilograms. Okay, and we don't know what his speed is right now. All right, but the tank we do know is going to go off at 2 meters per second. So let's go ahead and fill in the tank there. Okay, so remember it's 10 kilograms wide, that's one box, and 2 meters per second tall. Okay, all right, so now the hard part. Let's go to this. Let's see if this works. Okay, so let's do, oh wait, I'm in a different browser window now. Okay, so let me get my pencil. And let's use another color. Okay, so here's going to be the astronaut. Okay, and this is going to be the tank. All right, so let's look at our numbers. Okay, so remember what you're going to do is you're going to fill in these 4 boxes first before you do anything else. So these 4 here, you're going to fill in first. Okay, and that's simply momentum, which we know. Okay, P equals mv. Okay, so let's go ahead and try to fill these in. So the astronaut's momentum before his mass is 80, and he's not moving, so that's going to give him a 0 momentum to start with. Okay, all right, and then the tank has a mass of 10 kilograms and 0 velocity to start with, so that's going to give a 0. Okay, and I went ahead and wrote kilograms out of habit, but in my class at least I said if you want to leave out the units, you can leave them out here because it makes it a little less confusing. Okay, you really should have them though, so your call. Okay, all right, the momentum after, okay, the astronaut is still 80 kilograms of mass, and we don't know how fast he's going here. right? Here we don't know how fast he's going. Okay, so we're just going to put that is going to be called 80 V. All right, and then the tank afterwards has a mass of 10 kilograms and a velocity of 2, so that's just going to be 20. All right, so that's step 1. So step 1 is fill in 4 boxes with P equals MV. Okay, step 2 is going to be add vertically what we know. Okay, so remember, this is the system total down here. So what we're trying to do is we're trying to add this direction to get the total. So here I have 0 plus 0 is going to make 0. Okay, and then in this column here, I have 80V plus 20. So this is going to be 80V plus 20. Okay, all right, so that's step 2. Now, in step 3, okay, you're going to do your change. Remember, this is your delta P, which is final minus initial. Okay, here's your final, and here's your initial. Okay, so delta P equals P final minus P initial in each row. Okay, so here in the first row, I'm going to have 80V minus 0 is just going to be 80V. Okay, and in this row, I'm going to have 20 minus 0, which is just going to be 20. Okay, all right, and now what I'm going to have is I know that both the change in momentum and the system total change, or the system total change and the addition of the change in momentum both have to be 0. Okay, so now I'm going to set up 2 equations and solve. Okay. All right, so am I going to have room for this? I don't know if this is going to work. All right. Okay, so let's set up first the easiest one, which is this system total looks a little simpler. So I'm going to do the final, which is 80V plus 20, okay, minus 0, that's this one, because I'm doing this minus this is going to equal 0, which is this. Okay. All right. Okay, so now this 0, who cares? So I have 80V plus 20. All right, if I want to solve for the V, I'm going to have to subtract 20 from both sides. So I get 80V equals negative 20. Okay, and then I can divide by 80 to cancel this on both sides. So V is going to be negative 2/8, which is negative 0.25 meters per second. Okay, and that's going to be my velocity. All right, now if I do the same thing with this column, okay, where can I do that? I can't write down here. See if I make this a little, okay, I'm going to try to write it under here, okay, make this one a little bit bigger, okay. All right, here, when I look at this last column, I'm going to have 80V plus 20 makes 0, okay, so I'm just going to write over here because I don't have space. So 80V plus 20 equals 0. Again, I'm going to subtract 20 from both sides. Okay, so then you can see that this is coming out exactly like the other one, and now I'm out of space, so I'm going to divide by 80, just like on the last one, divide by 80. And then my velocity, again, should come out to be negative 0.25 meters per second. Okay, and those answers need to match. If they don't match, then you know you did something wrong. All right? Okay, so now the last thing I have to do now that I have that is let me go back to my thing here, my graph. All right, so 0.25, I mean, it's negative, all right? So if this is 1, this is 0.5. So 0.25 would be about halfway. This is going to be really hard to draw. Okay, about halfway there. It's very hard with this pen. Okay, so basically here I can see those are each half a box. So I'm basically like 1 box and 2 boxes and 3 boxes and 4 boxes. Okay, and here I see 1, 2, 3, 4 boxes. So I have a negative 4 and a positive 4, and remember my initial momentum was 0. All right, so that is kind of sloppy and probably confusing, but it's the best I can do at this time. I'll try another one later.